Hello everyone, this is the experimental setup for the metal recovery by electrochemical method. So this setup has mainly 5 components. First one is the reservoir tank, which is here, and second one is the pump which will circulate the solution, and third one is the rotameter from which we can control the flow rate. Third one is the cell, electrochemical cell, where these two electrodes are situated. First one is the graphite electrode, and the middle one is the copper electrode. So the fifth component of this setup is this current controlling unit, from where we can control the voltage and the current.
Start.
So objective of this experiment is to recover the copper from the copper sulfate solution. So basically what we are doing here is we will keep a copper sulfate solution of known concentration in the reservoir, and this solution will be pumped to the cell by this pump, and in the cell the copper will be deposited, copper ions will be deposited in the copper electrode. And the resulting solution will come back to the reservoir, and this circle will be continued with the electrodes connected to the current. So the oxidation reduction reaction will happen inside the cell, and the copper ions will be deposited in the electrode, and as the copper ions will start to deposit in the electrode, the concentration of the same will be decreasing in the solution. So we have to measure that concentration with after a specific interval of time, so that we will see that the copper concentration from the solution is reducing with time. So now we will start the setup. So this is the switch for the pump. So now pump is on, and the pump will put the solution into the electrochemical cell. As you can see, that cell is being filled by the copper sulfate solution. And after it is filled, it will come back to from this port, it will come back to the tank again. So now we will switch on the current. So as you can see, now the cell is filled with the copper sulfate solution. So the resulting solution is coming out again to the tank, and the pump is recirculating the solution again to the cell. So now we will switch on the current supply. So now we are switching on the current supply to the cell, so that the electrochemical reaction starts to happen inside the cell, and copper starts to deposit in the copper electrode. So now we have to set the voltage to 2 volts. And record the current at 2 volts. What is the current supply that we have to note down. And this is the rotameter. From here we have to set the flow rate at 2000 ml per minute. This is the knob for fine tuning the flow rate, and from this also we can control the flow rate. So now the flow rate is at 2000 ml per minute and the voltage is 2. So at this point we have to take a sample from here. Okay, this will be the sample for T0 for set 1, and also note the current. So like this, after each 5 minutes of interval we have to note down the current and take another sample from here. So with these samples we have to continue this up to the T30, that is 30 minutes. So we have to take totally 6 samples at 5 minutes of interval. So after it is done, then we will take this sample to spectrophotometer to measure their absorbance at 810 nanometer. And
That.
so after taking the absorbance in spectrophotometer, we calculate the concentration of the result of the copper sulfate solution. So basically what is happening here is that as the copper sulfate solution is going into the cell and the cell is connected to the current, so the copper ions will be deposited in the copper electrode, and as the copper ion is deposited in the copper electrode, the resulting solution, the copper concentration in the resulting copper sulfate solution will be decreased with increasing time. So we have to measure that decreasing, how much it is decreasing. That's why we are taking the sample at each 5 minutes of interval and checking its concentration. So from the absorbance we can calculate the concentration of copper sulfate in the solution by using a standard curve of absorbance versus concentration.
That.
So we have to repeat the same for the second set, where we will keep the flow rate same but increase the voltage to 2.5 volts. So here we have to repeat same, like taking 6 data at T0 to T30 after each 5 minutes of time interval. We have to record current and take sample for measuring the copper sulfate solution. So after second set, for third set we have to repeat the same but with increasing the flow rate to 2500 ml per minute. Here we will keep the voltage same but we will increase the flow rate to 2500. For this also we have to take 6 samples at 5 minutes of time interval. So for each data point we have to record 2 things. One is current and second is the concentration of copper sulfate solution. So now the reaction is happening inside the cell. As you can see, the electron flow. So this is the graphite electrode, this is anode, these two are graphite electrode, and in between this is the copper electrode, that is cathode. So here the oxidation is happening in the graphite electrode, and in the copper electrode the reduction is happening and the copper being deposited in the copper electrode. So you have to take the sample from here in this glass vial and take this vial to the spectrophotometer for measuring the absorbance.
Start.
So this is the spectrophotometer. Uh, Here we have to take the absorbance in basic mode. So now you can see that this is in the basic mode. So we will enter. Now this is the wavelength that we want to check our sample. But here you can see it is now at 546 nanometer. So we have to change the wavelength. We will go to wavelength and then press 810 and enter. So now you can see that the wavelength is set at 810 nanometer. So why we are taking the we are setting the wavelength at 810 nanometer? Because the absorbance of light of 810 nanometer of wavelength is highest for copper sulfate solution. That means copper sulfate solution will absorb highest amount of light which has wavelength of 810 nanometer. So we are taking the absorbance in this particular wavelength. So after setting the wavelength, we have to pour our blank, which is water, into the vial. And we have to rinse it with the blank solution. So after taking the blank solution, we have to put this into this slot, keeping the transparent side in this way, because the light passes from here to here. So our transparent side of the vial should be like this, not in this way. So after placing the vial, we have to close the lid and check here what is the absorbance for this. So as you can see, the absorbance for this blank is 0.062. So now we will press the 0 to nullify this absorbance, because this absorbance is coming not for copper sulfate. This is the absorbance for the solvent in which the copper sulfate is dissolved. So we are auto zeroing it to nullify this absorbance. So as you press 0, now it is nullified, so the absorbance is showing as 0. So after this, you have to take your sample. But before measuring the sample, you have to rinse your vial with the same sample. This vial has two transparent side and two opaque side. So you have to place the vial like this so that the light passes through this transparent side, not from this opaque side. Okay. So as you can see here, the light passes in this way. So we have to place the vial in this way so that the light passes through the transparent side. So basically here the light will pass from this point to this point, and in its course it will be absorbed by the copper sulfate solution, and some amount of it will be transmitted. So the amount of the light which is transmitted will be recorded by a detector, light detector, and based on that it will show us the absorbance here. So absorbance is the reciprocal of transmittance. So the more will light will absorb, the less will be the transmittance. But here we will record the transmittance. You can see that our sample has absorbance of 0.71. So like this, you have to measure the absorbance of all the samples that you have taken. That is 6 samples for each set. And with this absorbance and using a standard curve of copper sulfate solution, you can measure the concentration of your samples. Hello everyone, this is the experimental setup for the metal recovery by electrochemical method. So this setup has mainly 5 components. First one is the reservoir tank, which is here, and second one is the pump, which will circulate the solution, and third one is the rotameter, from which we can control the flow rate. Third one is the cell, electrochemical cell, where these 2 electrodes are situated. First one is the graphite electrode, and the middle one is the copper electrode. So the fifth component of this setup is this current controlling unit, from where we can control the voltage and the current.